This is a straightforward question about torque. It asks us to look at these two forces. I think it's assuming that this doesn't weigh anything. It's just asking about the torque caused by these two forces. So there's going to be two torques, F1, torque 1, torque 2 caused, twist 1, twist 2 caused by this force working at a distance, this force working at a distance, these lever arms. By definition, torque is equal to the perpendicular part of the force to the lever arm, or just leave the force alone and consider just the perpendicular part of the lever arm. Here we already have a, what is this? This is a clockwise torque here caused by F1. So torque of F1 is caused by the force itself. It's already perpendicular to the lever arm. The length of the lever arm is the full length, L1 plus L2. This force has a, I think I will work with this form for torque. This force here, this force is lifting upwards perpendicular to the lever arm, and this force is working parallel to the lever arm. Of course, I could have drawn it here. I don't want you to think that this force is working nearer than this origin here. In fact, I mean, this is a force diagram, so it's absolutely it's just a mathematical construction. It's all forces are working right there, and it's completely arbitrary, the scale that I draw this on, because force vectors don't actually have any real displacement in location. They exist in a mathematical framework of a space of forces. Anyway, this I could have drawn my force triangle and look like this, and then maybe you might not worry that this force perpendicular is actually has an effect right there at the origin of all of these forces. And there is only one force, this F2, and these are just the components. These are the parts. F perpendicular and F parallel together make F2. Anyway, by geometry, I can see what this F perpendicular is, the effective part of the force causing a twist. This parallel part of the force just drives the lever arm into the pivot, but it doesn't actually do any twisting. So then the torque here, torque is force perpendicular. The force perpendicular times the lever arm. The lever arm here is much closer, it's just L1. And the force perpendicular is, this side is opposite of the known angle, so that will be proportional to the sine theta of the F2. And there's the much shorter lever arm. So, and this is in the, this is in the counterclockwise direction. So give yourself appropriate signs, plug these values in there, and then you can come up with a net torque. A negative torque would be in the this direction is negative, this direction is positive for torques. Counterclockwise, to be consistent with not geometry, trigonometry, where we consider these as positive angles.